Redox reactions always involve two half reactions, one for oxidation and one for reduction. In an electrochemical cell, these half reactions can be separated to harness the flow of electrons. Electrochemical cells come in two main types: Voltaic or galvanic cells, which use a spontaneous redox reaction to generate electrical current. The other type of cell is known as an electrolytic cell, which requires external electrical energy to force a non-spontaneous chemical reaction to occur. In both types of electrolytic cells, oxidation always occurs at the anode and reduction always occurs at the cathode. To remember this, oxidation and anode start with vowels, O and A. Reduction and cathode start with consonants, R and C. Batteries are real-life examples of voltaic cells. Lead-acid batteries are commonly found in cars. Lithium-ion batteries are used in phones, laptops, and other portable electronics. The voltage a battery can produce depends on how far apart the two metals are on the activity series. A high-voltage battery uses metals that are far apart on the activity series, large difference in reduction potential. A low-voltage battery uses metals that are closer together on the series. Electricity is simply the movement of electrons. When the two half reactions are physically separated into different cells, we can connect them with a wire, allowing electrons to travel and create an electrical circuit. For example, zinc spontaneously reacts with copper 2+ ions. An electrochemical cell can be created by connecting a zinc strip and a copper strip with a wire. Placing each strip in a solution of their respective ions, zinc 2+ and copper 2+, like zinc sulfate and copper 2 sulfate, electrons flow from the zinc anode to the copper cathode. Zinc loses electrons, oxidation, becomes zinc 2+ ions. Copper ions gain those electrons, reduction, and become copper solid. To maintain charge balance between the two solutions, a salt bridge or porous membrane allows ions like sulfate to flow between the two compartments. In this setup, zinc is undergoing oxidation, so it is the anode. Copper 2+ ions are undergoing reduction, so the copper strip is the cathode. The flow of electrons through the wire is the electrical current, and the redox reaction is spontaneous, which means this is a voltaic cell. Electrolytic cells are used when we want to force a chemical reaction to go in a direction it naturally wouldn't go. One common use is electroplating, where a metal is deposited onto the surface of another object. In this example, we have an electrolytic cell with an anode made out of silver. At the anode, oxidation occurs. Silver atoms lose electrons to become silver+ ions. A cathode, which is a spoon, at the cathode, reduction occurs. The silver+ ions gain electrons and are deposited as metallic silver onto the spoon's surface. An external power source provides the energy needed to move the electrons and drive the reaction, since this process is non-spontaneous.